Ethylene, aka ethene, according to the IUPAC name, is one of the smaller hydrocarbons that are found in petroleum, probably the most useful due to its double bond that occurs between those two carbons. Have a look at all these hydrocarbons. These all exist in this soup we call petroleum. Now, ethylene, being the smaller one, is only available in small proportions in comparison to the larger ones, which kind of dominate this soup. We use fractional distillation to separate the different hydrocarbons contained within liquid crude oil or petroleum. In our example of ethylene, because it's such a small weighted hydrocarbon, when it moves from its gaseous phase to its liquid phase, it doesn't really need much energy or heat. Therefore, it recondenses at the top of our tower right here. Larger hydrocarbons are broken down into smaller ones using a process called cracking. Now, there are two types. The first one we want to look at is called catalytic cracking, and this just involves using a catalyst to break down larger ones into smaller ones, as you can see in the blue writing. There's also one called thermal cracking, which is either uses steam or heat, but essentially it just uses heat energy to break those bonds to make smaller hydrocarbons, because primarily the ultimate goal is to produce really this and this, because that's our ethylene, which becomes really useful later on. Now, Tyrone is also addicted to crack. Because ethylene has that highly reactive double bond, it can be readily transformed into many useful products. So for example, if we brought along another random molecule such as this one, that double bond can open itself up quite easily, and we can add these two things to this alkene, making it become an alkane. Look at that. Damn, that's good. Let's look at a few examples of how ethylene can react with other substances. So for example, if we reacted it with, say, hydrogen gas, the product that we would produce would be ethane, because all we've done is open up that double bond to produce this molecule. But how about we, instead of hydrogen gas, maybe we should react it with, say, bromine. Now, bromine would produce something like, I hate drawing this, but let's say we put a bromine there and a bromine there. No longer is it an alkane of ethane, it's whatever you would call that, 1,2-dibromine. But it's not just, molecules that only contain two elements. You can actually react with any number of elements within a molecule. Probably water would be a good one, because the product, if you look at it, would be something that looks like this. And what do you know it? It's ethanol. Good times. The addition of hydrogen gas to an alkene is known as hydrogenation, and this usually occurs by heating ethylene in the presence of a metal catalyst such as platinum, but there are other examples of reactions of alkenes. In this example, you can see that we've added either a bromine or a chlorine atom. Now, this process is known as halogenation because both these atoms come from the halogen group. No surprises there. There's also hydrohalogenation, which is really just the addition of hydrogen chloride gas. And finally, there's also a thing called hydration, which is the addition of water to an alkene. So I forgot to highlight it, but those ones. These are all hydration reactions, and ethanol being probably a more common one, I think.